Good morning, everyone. Today, we are here to present our Advanced Computing Concepts project, that is, Web Search Engine, done by Nancy, Ifaz, Likhitha, and myself, Kumar, as a group. In this project, we are going to discuss about what is Web Search Engine, how it works, what features we added, what concepts we use to develop a web search engine, and finally, a demo video to show our implementation. Let's talk about the basics of how a search engine find web pages, what they do with the web pages they find, and how they decide what results to show. When we are using a search engine to find the closest coffee shop, we probably do not think about the technology behind it at all. We all know about a Tim Hortons famous coffee called iced cappuccino, and you want to try it? If you search for iced cappuccino near me, the search engine will show you nearby shops selling the drink because your search engine indicated your location. You might even see a map to help you find them. So, search engines are constantly working to scour the web for content, organize it, and then display the most relevant results to searchers. But later we might wonder, how did that search engine do that? How did it sort through the entire internet quickly and chose the results we saw on the page? Each search engine uses its own software program, but they all work in a similar way. They all perform three basic tasks. First, they examine the content they learned about and have permission to see. That's called crawling. Second, they categorize each piece of content. That's called indexing. And third, they decide which content is most useful to the searchers. That's called ranking. If we take a closer look to how these work, search engines crawl the internet to discover content like web pages, images, and videos. Each search engine uses computer programs to make that way through the pages. These are known as crawlers or bots, which is short for robots. The bots hop from page to page by following links to other pages. These bots never stop. Their sole purpose is to visit and revisit pages looking for new links and new content to include in the index. Indexing is the second part of the process. The index is a gigantic list of all the web pages and content found by the bots. The search engine uses this index as a source of information displayed on the search results pages. That covers crawling and indexing, which just leaves us with ranking. Think about what happens after you type in a search. The search engine compares the words and phrases to its index and looks for matching results. What if it brings up hundreds of millions of matching results? This is where the next important task kicks in, that is ranking. There were literally hundreds of ways search engine determine rank, including things like words on the page, the number of other websites linking to it, and freshness of the contents. But no matter what formula they use to determine the rank, the goal remains the same: to try and connect the searcher with what they are looking for. These are the concepts that we use to develop our web search engine. Regex for regular expression, hash table for storing URLs, Boyamore for searching the words, edit distance for word suggestions, and finally sorting algorithm for ranking. Let's see how it works by a flowchart. First, user gives URL as an input. URL is sent for validation. If it is not a valid URL, user will be asked to enter URL once again. If URL is valid, web crawling process will be started and all the visited URLs are saved into a hash set, and later these URLs in this hash set are converted into HTML files using JSON HTML parser. These HTML files are converted to text files so that words can be searched easily. Users enter a word that he wants to search. The word will be searched using Boyer-Moore algorithm. If word doesn't found, user can search another word, and if word is found, then sorting will be done, which is ranking, and top 5 web search results are displayed to the user. Understanding how this process works can come in really useful. Let's see how it works and the different algorithms used to make our search engine and their implementation. Over to Nancy.
Hello everyone, I am Nency Kundaliya. Today I am going to talk about web crawler as well as HTML to text conversion. Now what is web crawler? So a web crawler is also known as a spider, and it is a type of bot which is typically operated by search engine like Google, and its main purpose is to index the content of the website across the internet so that those websites can appear on search engine. Now, what is web crawling? So a web crawling can be referred as the process of finding or crawling the web for any kind of data, For example, Google has its own crawler, which is Googlebot, which includes mobile and desktop crawling. The other use of web crawler is to create a copy of all the visited pages for later processing by a search engine. How web crawler works. Let's take one example. Like we want to fetch the URLs of one site which is www.uwindsor.ca. So web crawler can work in this way, like whenever we enter the site name www.uwindsor.ca, it will fetch all the URLs which are in this website, like any accommodation or any events URL or any students URL. In this way, web crawler will work. Regex. A regular expression is a sequence of characters that specifies a search pattern. So, whenever we want to search about any specific pattern such as any email or any phone number pattern, at that time we can use regex. Crawl depth, it refers to how many pages a search engine's bot will access and index on a site during a single crawl. So let's take one example. So the big green node is depth 0, which is the home page, and the lighter green nodes are depth 1, which are the URLs linked from the home page, and so on. So in this way, whenever we give depth 1, so the search engine bot will access the content of the depth 1. Now HTML to text conversion. So why we need this? Whenever we see any HTML pages, at that time there is a lot of component in one HTML pages like images, navigation bar, links, any URLs and so on. So at that time it is really hard to search for any specific word. So whenever we convert this HTML file into text file, it will become easier for us to search about any specific text. Now what is JSOOP? So JSOOP is an open source Java library which is used mainly for extracting the data from HTML files, and it provides a feasible API for fetching the URLs and extracting and manipulating the data. It uses some method of HTML5 DOM as well as CSS selectors. Now we have implemented two methods in this project. One is for saving the HTML file and other one is for saving the text file. We have given one specific path for saving the HTML files, and we have added that files into a hash table. After that, we have converted this HTML file into this text files for storing, and we have given one specific path. And after that, this text file will be helpful in searching for a word. We have provided a link that runs all the operations on predefined data, but user can add their URLs with their own choice for performing all the operations. Thank you. Now Ifaz will go further.
Hello everyone, I am Ifaz Mahmud. Now I will talk about pattern matching. Pattern matching is used to check or locate a specific sequence of data or some pattern among raw data or a sequence of token. A pattern can be a simple character, a string, or a complex expression. Java pattern matching, also known as Java regular expression, is widely used for search, edit, or manipulate text. The Java regex package is the Java regular expression API to define a pattern for search. In our program, a regex is used to find a website URL or suggest similar words among the text file. To use Java regex, we have to import java util.regex package. Then we use the pattern compiler class to define the pattern. It compiles and returns the instance of the pattern. For our website search, we used a pattern similar to HTTP or HTTPS : and then / followed by www, then a dot, then any character or a symbol or a number, then followed by a dot and then any number or word, and so on. After defining the pattern, we use the pattern matcher instance to find the pattern from the text file for further use. The next feature of our web search engine is the word search. Word search is one of the most important features of a web search engine. It is implemented through a pattern search algorithm. There are several pattern search algorithms like naive algorithm, brute force algorithm, Boyer-Murray algorithm, North-Muris-Pratt or KMP algorithm. We have used Boyer-Murray algorithm because it uses information gathered during pre-process to skip maximum number of steps, where the naive algorithm passes the pattern step by step. The Boyer-Murray algorithm runs faster when the pattern size increases. For a worst case scenario, the Boyer-Murray algorithm runs big O of mn time, where m is the length of the substring and n is the length of the string. The Boyle-Murray algorithm returns the offset of the index of the word, and if the word is not found, then it returns the length of the text. For our program, we use the Boyer-Murray algorithm to find the number of the occurrence of the word of a text file. Then the occurrence and the file name is stored in a hash table for page ranking, which will be discussed by my another groupmate Likhitha.
My name is Likhitha and I'll be explaining word suggestion and page ranking. Okay, word suggestion is known as a spell auto checker also, which is a very in-date great perk that is widely used in several system applications that aids users to find good outcomes and webmasters avoid losing a user disappointed about missing of no data or any simple wrong query. This feature is available in almost all search engines. Generally, to there are two approaches. The first one is where the system helps to correct the text as we type. Another approach is to give suggestions for the word we type. In many cases, these are combined and given as a single feature. Google primarily makes use of this functionality by cross-referencing the keywords that we enter with the dictionary. If it is not found, it suggests a possible replacement. For this, we have used edit distance concept to implement this functionality in our project. And there is an example where Google uses this functionality beside. And the implementation of this we have done using edit distances. Edit distances are mostly used in natural language processing, where automatic spelling modification can evaluate applicant modifications for a spelling error by originally referred out of a dictionary that are similar to misspelled words. Generally, edit distance measures how dissimilar two variables are to each other by calculating the number of operational processes necessary to convert one string to the other string. For suppose we have two strings x and y, where x is the initial string and y is the target string, then the edit distance is to find the minimum number of changes to transform x into y. The main operations are substitution, insertion, removal of a character in the string, and it is also known as the Levinston distance operation. If the searchable word is not discovered within the records, a method has been implemented to calculate the edit distance between both the searched word and all the other words throughout the record. If it resembles the edit distance of 1, the user will then be proposed an alternative word. There are some steps to determine how a word would be most comparable, and there are as follows. Firstly, if it is the most closely related to the input string in terms of edit distance, or if two or more words have about same edit distance, the most related word was the one with the nearest edit distance that appears the most frequently within dictionary. Or if numerous words have same distance, measure and count, the most related word is the one in the first, which comes first in the alphabetical order. If there is no such words with the maximum edit distance of 2 are found, the message will be displayed to the user. And the next concept is the page ranking. PageRank is a Google search technique that ranks sites on the internet in search engine results. PageRank computes a rough figure of how relevant a site is by calculating the number as well as reliability of links to that page. The estimation of PageRank may take several repetitions through the collection to modify roughly PageRank values to more closely resemble the hypothetical true word. And there are some examples which is where is the highest number of pages and it consists of highest number of links. And page B is considered as a high importance because it is connected to page A. And the other pages which are low, In the implementation, we have used sorting technique in this to implement this page ranking in our project. And we have the sorting technique we have used is merge sort, and it runs in O of n log n time, where in first all pages will be screened for information retrieval, following scanning, where all the websites at which identified word occurs are indexed depending on the frequency. The pages were being sorted utilizing Java collection methods, which by default uses the merge sort algorithm. In our project, we will show the user our top 5 search engine results based on page ranking. And these are the references we have used for our presentation.
Now I will show a live demo of our project. In our project, there are 7 classes. The main class is website search engine, and the web crawler classes is used to crawl the website. This class uses Java regex and JSON. And then the web HTML parser class is used to save the web pages and converting the HTML file to text file. And then the word finder class is used to find a word using Boyer-Muller algorithm. And all the classes uses the pathfinder classes to go to the directory of the files. If we start our program, it will ask us for a URL, or it has a predefined website. So let's see what happens if we give a random URL. It gives us an error that the URL is not reachable. Now if we give it a valid URL, it will start crawling all the possible websites. And all the files has been saved to this folder in a text format and also in a HTML format. It will take some time to crawl all the websites. After crawling, it will ask us to search a word. If we search a word like campus, it will show the number of occurrences of the files, words in the files, and provide a rank of the file. If we go to this link, you can see the campus word is here and also here. If we go to another link, you can see the word campus is here. Now let's see if we provide a wrong word. It will show us that the word is not found and it provides us a similar word. If we now stop our searching, it will ask us whether we want to delete all the files or not. If we enter yes, you can see all the files have been deleted. It will ask us whether we want to go to the main menu. And to exit the program, we have to press 3 to exit. Thank you.